Prepare to discard your mental blinders. CounterThink with Mike Adams is now live on Infowars.com.
So much that we're told in the name of science, and there's a demand that we surrender to whatever we're told in the name of science, as if science is this unassailable magical kingdom of truth. And this magical kingdom can say anything. As long as it's in the name of science, we are required to believe it. It could be vaccine science. It could be pharmaceutical science. It could be psychiatry. It could be cosmology, mathematics, or who knows, anything, right? But it's demanded that we believe it. And yet, in so many cases, I mean, think about it. Where in humanity have you ever found a group or a tribe of people who couldn't be corrupted, who wasn't biased, who wasn't capable, or who weren't capable of failure? Everywhere you go, in any tribe, in medicine, in finance, in government, in education, you find that when people have power, they exploit it and they abuse it. And they end up pushing a lot of falsehoods, things that are designed to manipulate people rather than really empower them. And for us to look at science as a community and say, no, these people are perfect and this process is perfect, is itself faulty logic. Doesn't mean that we can't learn things from science, because of course we have learned many things, and I'm a scientist myself. I run a science lab and we use science every day. Science can teach us a lot. But when science is used to beat us over the head, to say you must kowtow to this demand, and that only scientists can be correct, and people who aren't scientists don't have a right to participate in asking questions, because, well, then they're saying that they're a priesthood, you see. It's a bunch of priests. It's a bunch of people who are unassailable and incorruptible, you might say. And I think that that's nonsense. And so part of what we do here on this show, CounterThink, is we dare to ask some very big questions. And the questions that we're asking include questions about science and medicine, the nature of reality. We're going to have guests on in the future talking about heavy metals poisoning, guests talking about finance and the Federal Reserve and fiat currency, history, lots of things. But a guest I had on recently, his name is Jessome, and we talked about the Big Bang Theory. We talked about the origins of the universe and time, and what is the nature of time. And that got me thinking about a lot of big questions, and there are a lot of voices out there that need to be heard who are questioning mainstream science. There's Rupert Sheldrake, for example. There's Dr. David Lewis, who wrote the book Science for Sale. And, we had David Lewis as a guest on this show in a previous episode. And he's an EPA whistleblower. And as he has demonstrated, much of what we're told by the EPA or by the CDC or by the FDA, in the name of science, turns out to be completely bogus. Just complete nonsense. And when I see stories of how they claim, well, we found the God particle, the Higgs boson particle, or there's dark matter everywhere, there's string theory, and there's multiverses, and there's time travelers and all this stuff. I think, you know what? You people are making this up half the time. You're just making it up. You're just pushing the science fiction on mainstream media. It doesn't sound like you have any actual evidence for this stuff. Like, ask a string theorist, where's your evidence? Where is the experiment that shows evidence that supports your theory? And there isn't any. They're just making it up. They're literally making it up. Oh, it sounds cool. It sounds fanciful. It sounds like science fiction. You've got, an unlimited number of multiverses. Okay, well, where are they? How come none of them can be detected? You're just running a bunch of mental models, you see, is a lot of what these scientists are doing. So we, the people, have the right to challenge those mental models, especially when they have no actual proof in reality for a lot of this stuff. Like, where's all the dark matter? Where's all the dark energy? Their answer is, we can't see it. Oh, you mean so you just made it up, basically, because all your science falls apart the minute someone tries to detect it or prove it. You have no evidence. Anyway, we're going to talk to Glenn here and ask him some of these big questions when we get back, and see if I'm going down the right path, or maybe he thinks that we need to correct it. Who knows? We'll be right back.
Warning, take the red pill before viewing. CounterThink with Mike Adams.
You know, I don't know if mainstream scientists are writing the script lines for the Avengers comic books, or if it's the other way around, or the comic book writers are inspired by these so-called mainstream scientists. But there's a lot of what they tell us that seems really ridiculous. Now, there's the 96% of the universe is made of dark matter and dark energy that no one can detect. Well, how do you know it's there? Otherwise, our models don't work unless we create it in our minds. That's actually the answer in modern physics. So it's like, really, you just make this up. So when your theories don't work, you just throw a bunch of garbage at it. You just make it up. Oh, you could call it magical X powder. The universe is filled with magical X powder. Okay, whatever. Did you also write the script for the Avengers where that giant hole forms in the sky and all the aliens come out of it and Iron Man has to stop them? Because that's what it sounds like. All your multiverse theories, string theory stuff, that's what it sounds like. Okay, with that said, we're going to be joined now by Glenn Jessome, who also is a critical thinker. He's a mathematician, and he's been a science instructor, and he's developed his own theories on many things about the nature of our universe. And he shares some of my questions. Now, yeah, some of this I do in jest here just to try to poke fun at the scientists who are on TV talking about string theory and multiverse theory and, you know, time travel and all these things. It makes for great science fiction movies and lines and fascinating TV for those people who don't really know much science, I would say. But Glenn and I are really more serious thinkers, and so we're going to cover some of this here. Glenn, thanks for joining us again today here on CounterThink.
Thanks for having me again, Mike.
Well, it's great to join you. You know, we had a talk previously about the Big Bang Theory, and of course, that's blowing people's minds like crazy. Why are you doing this? Why are you daring to ask questions about the nature of our universe? I think you're causing frustration in the minds of people who thought they had it all figured out.
That's a great question. Actually, what put me on this path was a friend of mine named Pat Ryan. He was a pro hockey player in Germany. When he came back, he gave me a book called Einstein, His Life and Universe by Walter Isaacson. And when I found out that the developer of general relativity had doubts about it for the last 30 years of his life, and even 2 days before he died, he mustered the strength to try to get a pen to fix the flaws. So if the developer of the theory says it's flawed, I'm inclined to believe him. But the scientific community at that point, the theory took on a life of its own. They said he did his best work in his 20s and he's past his prime. That was sort of the narrative. But I actually was listening to Einstein that what happened was I read the book, got a lot of things flowing that I hadn't looked at in years. And like Archimedes had his bathtub, I had my shower. I'm in the shower and not even thinking about it. And it just came to me. It said, I know where the flaw is in general relativity. It's in something called Riemannian geometry, the geometry of curved spaces. I won't be getting into it right now because it's a pretty heavy topic. But that's where that's what put me on this path of being a scientific heretic. So
that's what you call yourself, a science heretic.
For lack of a better word, it's just it fits, right? I didn't bring it with me, but I have a degree in science, in mathematics from Dalhousie University, and you know, I'm not anti-science. I'm anti-law.
Well,
I'm anti-BS.
That's important to note up front. You and I both. I mean, I'm a scientist. I run a lab, and we're not anti-science. In fact, I think questioning the established science is part of the scientific method, right?
Oh, no question. And what you brought up earlier in your intro, which was fantastic, by the way, you talked about people being biased in money. Like I told you, in 1986, Stephen Hawking was let into the Vatican's Pontifical Academy of Science. 2 years later, he comes out with this book and has enough marketing money to send 10 million copies of one of the, you know, best-selling books that was never read because most people can't read it. But what I found interesting was at the end of that book, he wrote this: if we do discover a complete theory of the universe, it should, in time, be understandable in broad principle by everyone, not just a few scientists. Then we shall all, philosophers, scientists, and just ordinary people, be able to take part in the discussion of why it is that we in the universe exist. If we find the answer to that, it would be the ultimate triumph of human reason, for then we would know the mind of God. Stephen Hawking. That's how he closed his book.
Well, that's fascinating because that contradicts the science priesthood that is in power today, who they say that, oh, you little people who are not scientists, you have no right to participate in even understanding these concepts because they're so complex and they're so highbrow academia, you know, mental models and theoreticians and so on, that only real scientists can even talk about this stuff. But then you ask them, well, what are you talking about? And they say, oh, it's all imaginary dark matter. You can't see it, and we can't either. It's like, really? At least Stephen Hawking said, hey, a unified field theory, I think that's what he was referring to, a unified field theory should be understandable by everyone, right?
Yes, exactly. But here's my premise. My premise is the developer of general relativity said it was flawed. Quantum mechanics is incomplete. So you're trying to mesh a flawed theory with an incomplete theory.
Right.
Who does that make logical sense to? To me, you come up with a new overarching model and look at the good aspects of the previous models. But back to the commerce of it, because of the last line in the book, his colleague comes out with this. He's like, Stephen sold 10 million copies. I'm going to get me some of that. So his friend Paul Davies titled his book by the ta-da line of Stephen Hawking. To do what? Sell a whole bunch of books on theories. But the thing is, theories are testable, and they're testable sometimes in the lab. They're sometimes testable through thought experiments and just applying logic and first principles thinking. So when I said that the Big Bang was a Catholic creation myth, people can say that's an opinion, but I'm backing up with fact. I'm not just making a statement without fact. It's not that I like it or dislike it. That's irrelevant. The fact is,
it's a huge surprise to many people to hear what you're saying, that it was a Catholic sponsored scientist who originally proposed the Big Bang theory. That's what you're saying, right?
He was a Jesuit-educated priest. His name was George Lemaitre. You can look him up. They've named a moon crater after him. There's a NASA rover that was named after him. George Lemaitre this is not fiction. This is not conspiracy theory. 1927, he came up with the Big Bang theory, and he was the Vatican's Pontifical Academy Scientist President from 1960 until he passed away in 66. So he was revered. That if there were people within inside the Catholic Church that opposed the model or didn't understand it or didn't like it, that's possible. But at the top levels, the popes, they invite the scientists who are members of the Pontifical Academy of Scientists. So it's literally blessed.
All right, so maybe that's consistent with the idea of a divine creator. If you say that a creator seeded the universe, couldn't you say a creator caused the Big Bang? Because there has to be a prime causation behind events. Otherwise, we don't believe in cause and effect, and it means the whole universe couldn't exist. Doesn't there have to be a cause behind the Big Bang if there is a Big Bang?
Yeah. I was talking to a person, I forget what religion he was. I was in a big city, and I was talking to a religious person one day of an Eastern religion, and they said in their book, God said, do not curse time, for I am time. And I thought it was funny because most people are saying, we don't have enough hours in a day. I don't have enough time. We're all in the rat race. And I just thought it was quite interesting that, I forget the religion, but it was said by their God that don't curse time, for I am time, which I thought was quite interesting.
Well, it sounds like an Eastern religion, and I believe some Eastern religions believe that time is a giant loop, that time is a circle. In other words, it just repeats. It doesn't have a beginning or an ending. It just cycles through.
Yeah, I have some academic papers. I had one that I submitted to the Annals of Mathematics at Princeton, and I have a couple queued up to go now. And it's interesting that you have peer review is sort of like being with the cool kids and the popular kids. So if they don't like it, it doesn't matter if it's good, right, and true or changes things. It's a matter of, is it going to be liked to get published? So it's like politics and religion. popular ideas rise to the top, and it's not always about merit. That's why I'm a big advocate of meritocracy.
You're nailing it there. The scientific community, so to speak, actually is run like a high school clique, where you have to be part of the popular in crowd. You have to have the popular theories, the popular papers, the popular PhDs. This gets me to string theory, which I want to talk about after we come back from this upcoming break. But like you said, you got to be in the popular crowd to get published or to be given awards or recognition or even grant money for scientific research. And so really, science, as it's practiced today, is not about a search for truth. It's about a search for consensus popularity across the scientific community. And that's not science. That's just self-promotion, right? So we'll be back and we'll talk more about this. Stay tuned, CounterThink.
Now, they think you're a goldfish. I'm I've been betting on you my whole life. I believe in you. I don't think you're stupid. One man ever raped a woman, all genitals were cut off. And we're kicking these traitors' asses politically, and we're not backing down ever. I want to get these people. We're winning. I can feel the spirit rising. Can't you? We have broken their back. Yes, I can feel it. Let's go. Come on, 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 come on. Vengeance is coming. Fire is coming. The real revolution against you is coming, and you will burn in hell.
Countering the brain-dead propaganda of the status quo. This is CounterThink with Mike Adams, right here on InfoWars.
And so we're into some pretty heavy thinking right now about science and what is promoted as science or what is even accepted as science. And as we left off there in the previous segment in our discussion with Glenn Jessome, we were talking about how science, you know, the scientific community, so to speak, is really kind of a self-promoting cult. And if you disagree with the established theories, then, you know, you're tossed out. Your paper doesn't get published. You don't get the professorship. You know, you don't get the PhD. But if you go along with whatever's popular at the moment, then, oh, your career advances very quickly and you get, you know, asked on TV, you get book deals, all kinds of things. And I'm thinking about, you know, for example, Brian Greene. And Glenn, this is a question directed to you. Brian Greene, you know, he's got all these books about string theory, and he's been kind of a popular scientist, physicist of our time. And he always talks about string theory being, you know, creating everything. And, you know, I'm not attacking his personality or ethics or anything, but I don't think there's any evidence for string theory. And yet you've got all these PhDs about string theory and all these papers about string theory. But the very premise of it seems to be untestable. And how can you have a theory if you can't test it? I mean, how can you believe in it? There's no way to test it. There's no evidence. There's no way to disprove it or prove it. It's just a mental model, isn't it?
Yeah, you stemmed like too many thoughts at once there for me. So I'll try to put them in order. One of the developers of an iteration of string theory is Michio Kaku, and he's on one day on CNN explaining to them, you know, something to do with Fukushima that's real science and the fallout from that. And he's seen as an authority. Then I watch another video with Michio Kaku, and he's talking about and this, like we have width, height, and depth. And he's talking about fourth, fifth, sixth spatial dimensions. These are theoretical, but he starts giving them physical attributes. He says you can be going both up and down in an elevator in this sixth dimension or seventh. And in the eighth dimension, you can be, you know, be two places at once. And he gives all these physical attributes to spatial dimensions higher than 3. And I say, if he didn't have a DR in front of his name and a PhD behind it, and he had to go for a psychiatric evaluation, and he was saying these things, they'd lock him up.
Well, I guess you can travel both directions in 8 dimensions if you take enough psilocybin mushrooms or whatever. But I mean, he's talking about an acid trip or something, is what it seems like to me. That doesn't sound like real science.
Yeah, but he has the PhD, he has the doctorate, and so he has authority. What he says has weight. What I say doesn't have weight. And again, I don't bash science, but we have to look at the totality of reality. In totality of reality, science gave us thalidomide. Science gave us Fukushima. Right. Science gave us a lot of things that were bad, and so I encourage people to be discerning. Look at the good and the bad. You know, you talk a lot about vaccines. You know, some people say there are some benefits to vaccines. I haven't really seen any proven, but I've seen vaccine injury up close and personal. At 4 months of age, I was given a vaccine and I nearly died, and it was determined that I was allergic. So I wasn't given any more.
But you see, yeah, you bring up exactly the point that we're, I think, both trying to make here, which is if I challenge vaccine science with some common sense questions or critical thinking questions. Even I run, I take a vaccine to my laboratory. I run a mass spec analysis via ICP-MS of the mercury concentration in vaccines. And I say, look, there's mercury in flu shots. They say, you're not allowed to even say that. You can't participate in the conversation about vaccines because you don't agree with what we say vaccines are, which is 100% safe, 100% effective with no negative side effects. It seems like, you know, astrophysics and astronomy and just, you know, quantum physics, they have the same kind of attitude. They say you don't have the right to participate in this conversation unless you agree with us by default.
Yeah, I would encourage your listeners to look at one thing. When one individual has a vaccine injury, I would look at the McDowell triplets. Put that into YouTube. McDowell triplets. These were 3 triplets. I believe they were 9 or 10 months of age. They all got a vaccine for pneumonia. It turned out it was a bad batch. It had killed a 2-year-old. And these 3 children became profoundly autistic right at that time, and it was proven. So when you have triplets, you know, they lose their argument. That's what the parents say when they gave their interview. They said they lose their argument with us. We've been to geneticists, the McDowell triplets. So that's proof positive. But again, somebody say, well, that's not science. No, that's reality. This happened to these people. They're good people. They're honest people. They're just telling their story. And you know what? It's adding insult to injury, literally, when these people are called quacks and kooks. You know, and again, that's not my forte. I'm not a doctor. But I've studied enough vaccine science to know that there's a lot of commercial profit in it, and there's harm being caused. And I have another friend of mine, Brandy Vaughn, who says where there's risk, there must be choice.
Well, what you're getting to, though, I think, are the key narratives. You know, science, as it is presented to the public today, is a collection of stories. It's a collection of narratives, and some of these stories are metaphors. Some are myths. Some are accurate representations of reality, such as, you know, the acceleration of gravity, for example. But people need to realize that you're not being told actually the way things are. You're being told narratives and stories. Even, you know, you look at pharmaceutical companies when they're advertising antidepressant drugs, and they have on TV, they have like little green triangles, and they say, oh, these are the missing chemicals in your brain. You're deficient. And look, they lock into these neurons, and they show them locking in like keys in a lock. And they say, this is what happens in your brain. Well, the answer is not really. That's a fairy tale. That's a comic book version. You know, it's not real. And so often, even in cosmology, we're told these stories, you know, like Kaku goes on, you know, CNN or whatever, and starts talking about time-traveling spaceships and Warp 9 and stuff. It's just your myth.
Yeah, no question. And, you know, I have a question. Okay, I want to bring up another slide here that I had in my presentation, number 39. It's explaining Big Bang Theory diagram. When I first looked at this, I didn't know what to make of it. And now I actually know what they're kind of trying to say, but I've got a big, well, there's thousands of questions there, but there's a big logical one. If you look at the outer rim there, so what they're saying is if you go back to that light is inflation, where everything expanded without time. So somehow there's expansion without time.
Right, which makes no sense, but go ahead.
And there's that birthday picture of a Big Bang, which again, Dr. Pierre-Marie Robitaille, he got demoted at his university for telling the truth about it because it was outside of his scope of expertise, they said, but it really wasn't because the equipment is something he was very familiar with, as was the science. He took out a full-page ad in the New York Times to explain what was wrong with the cosmic microwave background. So moving up there of this shuttlecock diagram of the Big Bang, so basically what they're showing is a one circle slice is 3D space, and it's progressing along. But I've got a question. What's on that rim?
Right.
Where's the difference between space and nothingness? I want to see that.
Right. Good point. Because they're saying that the Big Bang actually created the very structure of space as it expanded.
Exactly. And this is what I'm trying to get through to you, too. When you keep going back to fabric of space-time, there is no fabric of space-time. We got to be careful. If you have a pot of water, okay, and I stir up the water, okay, you can create eddy currents in it. We boil it. We can do all kinds of things.
Glenn, we got to go to break here. Hold that thought. Okay, we'll be right back. You're watching CounterThink. This is Mike Adams with our guest, Glenn Jessome. We'll be right back after this break.
exposing the corporate media assault on your reality. It's CounterThink with Mike Adams.
You're watching CounterThink here on the InfoWars News Network, and I really want to encourage you to support this show and the efforts here at InfoWars. You can go to the InfoWars store at InfoWarsStore.com. They've got an incredible selection of health-enhancing products to choose from, and that's what funds this entire operation. That's why this show is possible. And anything that you can do to help support our ability to ask questions and speak freely and tell the truth and just basically be human beings who are self-aware, conscious human beings, you're not going to get the conversation that you're hearing here today from the so-called mainstream media. They will not ever dare ask these questions. And even speaking about media, our guest is Glenn Jessome. And Glenn, my question for you to lead off this segment is, when we see scientists in the mainstream media or the legacy media, whatever you want to call it, you see, Michio Kaku or others, how do we know whether we can even believe what they're saying? Because in many cases, their whole premise is that, hey, I'm a scientist, and you have to believe everything I say as a scientist because I'm part of this priesthood class of scientists. You can't question it. In fact, you can't even understand it. Only we, the scientists, can understand it, which is pretty much what the old Aztec and Mayan priests said, in human history, that only the priesthood have access to God. So what do you do with that?
I'm a practicing logician, okay? And I know from watching some of your stuff, you've studied logic too. You've studied formal logic. And the appeal to authority, logical fallacy, is quite well known. Because someone is authority doesn't make them right. If they're talking about something complex, then you have to break it down into simpler items so that you can understand it, which is what I'm trying to do with my presentation. I'm trying to break things down into simple. So rather than listen to a whole bunch of words you don't say and say, well, it's very complex, I don't know, but he must. That's not logic. That's not science.
Well, but so much of it,
science that agrees with logic is great, and morality as well.
Based on what you're saying there, then there's a lot of what we're being told in the name of science today that we have to question, because let's say when scientists come on to talk about chemistry and they make an assertion about chemistry, we can experimentally prove or disprove that theory. We can do the science. We can do the chemistry in a lab. But now they come on TV and they talk about multiverse theory and M theory and string theory and even, I don't know, quantum physics and the God particle and all this stuff. And it seems like even the discovery of the God particle, there's a lot of skepticism about that. Some people say that even that's a total hoax, that it's just a statistical, twisting of data. How do we even know what to believe anymore? That's the bigger question.
Well, it's what it comes down for each individual is, how does it impact them? And that's something that my cousin asked me the other day, like, okay, you're going to talk to Mike Adams about time and space. How is it relevant to the average person? And if you'd allow me, I would like to get back at that.
Yeah,
just
please.
Two quick slides. Quick slides. If you look at, we do a recap. We look at slide 22. Comparing Minkowski space and Jessome time space, Minkowski space time and Jessome time space. So they're looking at it from points, lines, planes, 3D space. They just stuck time in the fourth spot. But if you look at time as being the first concept, and line, let's say your singularity, and then you've got lines and planes, and you got 1, 2, 3, 4, 5 concepts, and they've got them in that order. And actually, I'm ordering them for them. They put time in the fourth dimension, and so it's after space. But if you look at what I'm saying the natural phenomenon of change is the first realm of reality. Points are theoretical in nature. They don't exist. Lines are theoretical in nature. They don't exist. Planes are theoretical in nature. And then when you have time and space, you're getting close. And like I was saying before the break, when you have a pot and you have water in it and I stir the water, I can change the medium, but that doesn't change the volume of the pot. And what they've done with the expansion of the universe model is they're looking at objects moving in volume of space, and they're saying that means space itself is moving away. And it's just like, if the water starts expanding while boiling it, it doesn't change the size of the pot.
Well, right. They make these arguments, but they don't give any logical reasoning behind it. They say
And
space
that's
is being created.
Yeah, exactly. And not to be rude, Mike, but they even fooled you because you keep using the vernacular of fabric of space time and treating time as a construct and all this stuff. And we've all been like, I had to think about it, and I didn't come out of the womb having a good knowledge of time. I just asked, well, what makes time the fourth dimension? And when I couldn't find any logic to support it, I said, okay, where could we put it that would be more beneficial? So if we say time is the first cause of reality, space is secondary, and the contents of space, which are fields and subatomic particles and atoms, that's our third cause to reality, and that we're going from simple to complex. And so to say that time is an emergent phenomena that comes from space, even the word emergent is a verb. Verbs are temporal.
Right. Okay? Well,
so I make the case that just logic, not me, don't believe me, logic indicates that the space-time is the reverse notion of what we're actually experiencing.
But the challenge we have here, though, is, of course, we have a very limited vocabulary, and the human vocabulary, from linguistics, was not actually created to describe mathematical phenomena, right? And even our math system, if you think about it, we're all operating, for example, in a base 10 math system. Well, why base 10? It's an arbitrary choice, frankly. Yeah. Maybe base 10 is not the right. Hold on a second. Maybe base 10 is not the right mathematical system from which to describe these properties of reality, quantum physics, for example. Maybe it should be base 2 or base 16 or something like that. I mean, how do we even know we're using the right tools?
Yeah, not to be splitting hairs, but you said something, mathematical phenomena. I talk about physical phenomena. Mathematics is a language, it's a description. And like my philosopher friend says, the thing is not the thing. If you write down your signature, they say that's a representation of you. If you take a photograph, that's a much more complex, sophisticated, gives more information, a photograph. Then there could be a video of you, a hologram of you, a clone of you. But the only thing in the universe that is Mike Adams is, as one of the comedians says, that meat puppet that's sitting in that studio.
The real physical person, right?
The real physical person. But what I'm saying is that their model is atheistic and deterministic, the model of the Big Bang. And what I'm saying, when you start contemplating time before space and time without space, you start talking about a conscious universe, and that's a whole different thing. So if we could look at slide before, because I know you're going to have some great questions just before we get to them. If we could look at slide 44, I would really appreciate it.
The conscious universe. Don't tell me you're not going to get into like a cosmic Gaia, are you?
No, I'm not. I don't follow anybody. Okay, now again, this slide didn't come up perfect. Hopefully it does.
That's because time and space have been warped in your slide. You're actually demonstrating exactly what you're talking about. That's brilliant, man. That is brilliant.
Yes. And the Pope said that God is not a magician with a magic wand. Well, impresses the heck out of me. I think it's a lot more.
Well, no, but just the point here, though, I don't want to get too deep into your theory here because people can go download they can go to counterthink.com and download the slides if they want. But more the question of how is a layperson supposed to know what is real, what is science fiction, when they're watching you or they're watching me ask questions, or they're watching, Kaku, Michio Kaku on TV, and he's a pretty entertaining guy. He looks like a pretty smart Japanese scientist guy, kind of fun to listen to. But what if half the stuff he's saying is just comic book science fiction? I mean, people need to be able to discern the difference, and sadly, it's hard to these days.
Oh, for sure. A book that I picked up that I really liked back when I was questioning things, it's called Asking the Right Questions, A Guide to Critical Thinking. It's a textbook. It was fairly dry, but it was a great little refresher. I taught at a private boys' school. I taught critical thinking and logic. And, there are some telltales. Be wary of people who are trying to profit and sell you things. Like, I have a lot of friends that like.
Glenn, we got to go to break. We've got 5 seconds. We'll be right back after this break on CounterThink with Glenn Jessome. Stay with us.
what you're told without knowing why is what they want. CounterThink with Mike Adams.
I know a lot of what you're hearing here in today's show on CounterThink may seem like kind of nebulous. Like, why does this matter? One reason it matters is because, you know, there's billions of dollars of government funding is spent, awarded to scientists to try to explore this thing. I mean, the whole super collider, the CERN super collider, is this search for smaller and smaller, quote, particles, you know, the God particle, as they claim to have discovered. They want to understand, you know, the subatomic particles and understand quantum physics and ultimately find a unified field theory. But they're burning through billions of dollars doing experiments that some people say really don't have an underlying theoretical basis that makes sense. You know, we're told things like in theory of relativity from Einstein and others who agree with that time is relative. We're told that, you know, the astronaut paradox, if you send two astronauts or you send one out into space and keep one on Earth, and they're twins, let's say, and the one you send out into space, if you accelerate that astronaut close to the speed of light, that they will experience time more slowly than the person on Earth who experiences time more quickly. And then the twin comes back from outer space and they're different ages. This is a common story that's explained by scientists. Glenn, what do you think about that whole relative time thing? Can two astronauts age at different rates depending on how fast they're moving relative to what? Relative to what? The sun? The Earth? What does it mean?
It gets into some nonsense about reference frame. In reality, there's one reference frame, the universe, and we don't know the size of it. And to make sense of the universe, we invoke reference frames. Interestingly, it was Einstein's papers of 1905, 4 of them. They call it his miracle year. The miracle was that they published them because he used other people's work without citing it. And when you do that, usually you don't get published. You can look that up online as well. But anyways, he convinced people that time was relative. You'll hear people say the flow of time, the arrow of time. Time flies is a very popular expression. I say time causes flight. Time causes arrows to go from one position to another position. Time causes a river to flow. So time, suggesting that time is relative is nonsensical.
But
now,
hold on a second. I'm pretty sure I remember reading some science papers or studies, articles about science papers that claim that time, I think they say, moves more slowly in a gravity well, like on the surface of Earth, versus being in orbit. It moves more rapidly. I forget which way it is, but they say there's a difference.
Yeah, there is. Okay, and it's interesting because right now they have quantum clocks where they can put 2 clocks, 2 centimeters difference now, and they'll tick at different rates. And they say that is proof of time dilation.
Yeah. And
what I say that is, I explained to my colleague Ron Hatch. Ron Hatch is somebody that you should know his name. People should know his name, and nobody does. Like, very few people do. GPS had the accuracy of meters, which was fantastic from space to locate things on the Earth, like down to the meter. That's excellent. In 1982, he came up with something called the Hatch filter, and he single-handedly came up with an algorithm that took GPS from meters down to centimeters. Okay, so when I was talking to Ron, I explained to him, look, they talk about putting 2 atomic clocks on airplanes and flying around the world in different directions, and then they compare the clocks, or you can take a clock and put it on a satellite and bring it back down. These are atomic clock, very high precision. Yeah. And I said, if 2 clocks are in the same place in time, one goes up on a satellite, goes around, they bring it back down, let's say, we put them next to each other, and they got different readings on them. If they're at the same place in time then and they're in the same place in time now, how could they have experienced different amounts of time? If they experienced different amounts of time, they'd never be able to be together again, because one would be in the future, one would be in the present.
Well, but wait a second. But how do you explain that they are together now and they have different measurements of time?
Yeah, well, it's funny because I don't want to take credit for this, and I asked him if he coined it. Ron is a very humble man, but I think Ron Hatch should have credit for what he calls clock bias. And this man has built satellite systems, designed and built satellite systems. And you can look him up on ronhatchgps.gov. He sits on the governing body, and he calls it clock bias. So it's a bias. Is that
kind of like white privilege? What is clock bias?
Clock bias means that there's a difference in the readings on the 2 clocks. They didn't actually experience a different amount of time. I had a real light bulb moment with a good friend of mine, Marianne, and I said to her one day, I said, I take 2 identical clocks, and they're both painted red. I put them out in the weather. I put them side by side. One has hands and one doesn't. I come back 3 years later. Are they both going to be weathered? She said, yeah. I said, so does the clock with no hands still experience time?
Well, of course. I mean, come on. The hands are just a representation of time for our benefit.
Exactly. But what people don't realize is that Einstein in his paper convinced people that time was that which clocks measure.
Well, okay, but still, but if you can consistently send, I'm sorry.
Oh, yeah.
I keep interrupting you. Sorry.
That's right.
If you can consistently send a clock into space and it consistently comes back as having experienced less time because it was moving faster, then doesn't that eliminate clock bias? Because if it's just random clock bias, wouldn't it be random?
No. There's nothing random about it. There's very advanced, complex mathematics. If I sent you one around paper, you'd see what I'm talking about.
Okay.
It's very complex mathematics, but it accounts for the clock bias. But the clock bias is not a different amount of time. The whole thing stems from, and I encourage you can see this on YouTube. They're simplifying Einstein's work now. It's called the mirror clock or Einstein's clock.
Yeah.
And people should look into that and see if they can debunk the thought experiment, because a thought experiment is something that we don't have the technology to do, but someday we may in the future. But sometimes we can glean things about nature and relationships by doing thought experiments. But it was Einstein's light clock experiment that convinced people that time dilates or that time is relative.
Well, as we can see from what was on the screen there, anytime someone is standing in front of a chalkboard full of 200 different mathematical symbols, they must know what they're talking about.
He's 100% right. He's 100% right.
Right, because he's got formulas all over the place and different kind of symbols and calculus. Wow, must be cool.
Yeah.
Okay,
yeah, see,
so clock bias.
I'm a different doc. Again, I should let Ron Hatch come on your show and explain it to you.
Yeah, I'd like to ask Ron about this clock bias and make sure that Maxine Waters doesn't hear about that term. She's going to use it as a kind of a racial thing. That you have to vote for Democrats because of clock bias.
Yeah.
In the midterm elections, watch out for that clock bias. You notice white people wear wristwatches. See, there it is. Clock bias right there. That's it.
Yeah. You're coining a term, man. You're coining my friend's term, and he can explain it. But because the clocks have two different readings on them,
yeah,
doesn't mean they've experienced a different amount of time.
Well, okay, I'm open to learning more about that. You're definitely warping my understanding of time at the moment. We've only got about 2 minutes left. What do you want to leave us with so that we actually cannot sleep for days about the nature of the universe and the cosmos? What would really mess us up that you've got in your head right now that's just begging, screaming to get out?
If people could realize that time is not the fourth dimension, if they could just realize that these spatial constructs and where we put time in the fourth dimension led people to treat time like a medium that can flow and travel. And what I'm saying is time is the cause of everything physical. That's the natural phenomenon of time. Clock time is an accounting for measurement. So one swing of a particular pendulum, that is a second. 1 year is a rotation of this planet around the Earth. So they're regular motions through a distance that we're comparing stuff. That's clock time. Clock time, natural phenomenon of time, two different things. And if you can get those concepts and hold them, I think you'll have a different appreciation and understanding of nature.
Okay. Well, you've given us a lot to deal with, a lot to think about, a lot of questions to ask. I know that in this short show format, we don't have the ability to, answer these big questions, but at least you're raising big questions. Glenn, in addition to your slides being available on counterthink.com, how can people follow your work? Is there another website, or you have a book or film coming out?
All I did so far is, and again, this started out as just a pastime for me, but all I've done is the Jessome Society. I set up a Facebook page. I've got, I think, like 17 friends on it right now. And I'm going to be putting out works. I'm going to start putting out videos. I'm going to be putting out open source peer review papers that people can review, because I've had issue with academics that can't find fault with my paper, can't say where it's wrong. And I know how it works. When nerds are policing nerds, if they can find fault, they say, here's the fault, here's how you made it. And
I like that. Nerds policing nerds with clock bias. There you go. That's the whole new political spectrum right there. Nerds policing nerds.
Don't give me credit for clock bias. That's Ron Hatch, a colleague of mine. Great guy.
But you did say nerds policing nerds. That sounds fun all by itself. No, Glenn, we're joking around, but hey, it's been great having you on the show. Thank you for joining me here on CounterThink. And folks, you know, a lot of big questions out there. Guys like Glenn are at least asking the questions, and it's up to us to pursue better answers. Thanks for watching. This is CounterThink.